All right. But let's do 2022 day 11. Let's see if we can figure out how to get this done. Day 11, monkey in the middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away, with your missing things. To get your stuff back, you need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. You take some notes, which is your puzzle input. All right, let's get our puzzle input. Get input 2022-11. Okay, so it looks kind of similar here. Monkey 0, monkey 1, monkey 2. There's only 55 lines, so there aren't that many monkeys. Let's just take a quick peek at how many monkeys there are. 7 monkeys total. Okay. Oh, no, 8 monkeys. Sorry, 8 monkeys total. And here there's 4 monkeys. I wonder if that's significant. Power of 2. Each monkey has... Let's do this. We can look at this at the same time. Each monkey has several attributes. Starting items is your worry level for each item the monkey is currently holding in the order they will be inspected. Okay, yeah, so this one has a bunch of starting items. Operation shows how your worry level changes as the monkey inspects an item. An operation like new equals old times 5 means your worry level after the monkey inspected the item is 5 times whatever your worry level was before the inspection. All right, now I can see plus. I see times, plus, times, and plus. Okay, so it's just those 2 operations. So we can actually, and all says new equals old, new equals old. So that shouldn't be too bad. We should just be able to parse out just what the operator is and the number. So plus 7. Test shows how the monkey uses your worry level to decide where to throw an item next. If true, shows what happens with an item if the test is true, and false shows what happens with the item if the test is false. All right. So what's this test? Divisible by 2319, 1317. These are a little bit different. So those are all primes, but we got a 2 here. 2 is prime, 3 is prime, 5 is prime. Okay, so they're all just primes. 2, 3, 5, 7, 9, 11. Oh, and 17 and 13. I know my primes. Okay, yeah, so those are all primes. I wonder if that's significant or if that's just for fun. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage an item causes your worry level to be divided by 3 and rounded down. Okay, so that's just integer division. The monkeys take turns inspecting and throwing items. On a single monkey turns and inspects and throws all of the items it's holding one at a time and in the order listed. Okay. Monkey 0 goes first, and monkey 1, and so on. When monkey throws an item to another monkey, that item goes on the end of the recipient's monkey list. Monkey that starts a round with no items could end up inspecting and throwing many items. All right. So, and then this is just walking through, and maybe we can use this for debugging. After round 1, the monkeys are holding items with these worry levels. Okay, you can see how the worry levels might grow. After round 3, round 4, round 5. Okay, so they're not growing too bad. Chasing all the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of items each monkey inspects. Count the total number of times each monkey inspects items over 20 rounds. In this example, the 2 most active monkeys expected 101 and 105. The level of monkey business in this situation can be found by multiplying them together. 10,605. Figure out which monkeys to chase by counting how many items they inspect over 20 rounds. What's the level of monkey business after 20 rounds of stuff slinging simian shenanigans? Go for the alliteration there. All right, and I'm guessing that if we're doing 20 rounds the first one, maybe the second part 2 is going to be, what about 1 billion rounds or something like that? All right, we got our puzzle input, so we don't have to worry about that. And the first part is just, I think, just a parsing problem. So here's what it looks like. Let's create our file here that's going to have the code. Nope, come on, comma. There you go. 1, 1. I did mud again. Day 11. Okay. So create the file, go to the file, fill in the snippet, day 11, and then over here we're going to run bacon. And we should get unsolved, unsolved. Ta-da! Okay. Parsing. So I guess what we need is a monkey. Struct monkey. And monkey's going to have a few things. It's going to have a items list, which is just going to be a vec of some number. We're going to have an operation, which I think we can just, let's make an enum for it, just called op. We have a test, which is going to just be a divisible. It's a divisible by a specific number. And then we have, I don't know, let's call it a destination, which is going to be the index into the monkey array. So make these uses. Is that all we need? Starting items, operation, the test, and then what to do if true and what to do if false. Okay. And now we just need to build up a bunch of monkeys. So we can just say monkey, which is a vec of monkeys. Oh, which means I have to derive default. Let's do debug default, because after I parse them, I want to print them out. And then we have to do derive debug default on enum op. And our operations are going to be multiply and add, right? So it's going to be multiply and add. The only issue is with Rust, you need for a default, for an enum, if you want to derive default, you have to mark one of these as default. And unfortunately, you can't just do this, because this has a variant. You think it would just be 0, but it'll complain. Yeah. Consider a manual implementation of default, or you can just put it on a unit thing. So I'll just put a no op here, just to have something as a default. Cowface Dude, hello. Cowface Dude says, I gave up on today's problem. Might take another stab once I'm done with your solution. Okay. Well, hopefully I can get through it. All right. So now all we're getting is 4 warnings, 3 warnings that we're not using things, and a warning that we got warnings. I always like to get an extra warning saying we got a warning. And now it's just a parsing problem for now. But it seems like these operations are straightforward, right? Okay, so we're going to grab the lines. Let lines equals aoclib read lines from input 2022 11. Now we say for line in lines. If we split on space, which is what I want to do, we're going to have to trim these things. So let trim is equal to line trim. And then we can say let words equals trim dot. Oh, can I just do that one line? Words trim dot split this dot collect vec of stir. Let's see, println words. Let's see, that should be what I'm looking for. Yeah, perfect. Okay, so now we need to create a monkey. Let monkey equals monkey default. And then we can say match words 0. So if it's monkey, we'll just create a new monkey. If it's starting, it's going to be a list of items starting at this offset that we need to parse. So can we do that all in one go? Can we say monkey items equals words of, so it's 0, 1, so 2 dot dot. Map word to parse, unwrap, collect. For now, let's just do this. Panic, can't handle yet. Words. I just want to see if this builds, because I hate writing a ton of code and then having to debug every single line. Stir is not an iterator. Oh, do I have to do iter here? Okay. And then what I can do at the end, I can't, oh, okay. Right, at the end I want to create a list of monkeys, right? So we're going to say println this and the self, what do I call it? Just monkey. And that should be an empty array right now because we're not pushing anything. Ooh. What happened here? Line 29, which is this. We were unable to parse because we got an invalid. Oh, I know why. I know why. Because there's a comma, right? We need to split on the comma. Okay, that means this has to be a little more complicated. Dang it. It looks like this. So let's split on this and then split on the comma. Let nothing stir list is equal to line dot split once. This unwrap, and then we can say this here. Maybe we can say stir list dot split comma space. Worked. Let's handle operation. Operation. And what is operation? Is just going to be, so that's 0, 1, 2, 3. So we're going to look at 4 and 5 for the operation and for, and it's either going to be a plus or an asterisk, right? So we can say if words of, I've already forgotten, 1, 2, 3, 4, 5 is equal to a plus. And we can say monkey dot op is equal to, then it's going to be op mul words 6 parse unwrap, else op oops, this should be add, and then we do mul. Right. So that's that. Vidal, hello. Vidal says, I'm once again going to spend an hour figuring out parsing problem. Yeah, this is turning into a big parsing problem, right? I have a bug here. Missing the colon. Crouch, hello. Crouch says, I hope you enjoy the problem. I mean the parsing. Yeah. Is this all this problem is? Is it just going to be a giant parsing thing? And now we should get the next one. Len is 6, but the index is 6. Oh, did I count wrong? 0, 1, 2, 3. Oh, yes, 4 and 5. Okay. Very good. Now what do we got? Test. Okay, so now we have to figure out test, and this time I won't forget the colon. Test colon. And all we care about is this last number, 0, 1, 2, 3. So monkey dot test is equal to words 3 dot parse dot unwrap. Okay. And I forgot the comma. And now if. So it's going to be if true and if false. So if We can say if words of 1 is equal to true with the colon, don't forget the colon, then we're going to look at 0, 1, 2, 3, 4, 5. So it's going to be 5. So it's monkey.dest.0 is equal to words 5.parse.unwrap. And then else, and now actually we're going to do something special here. We're going to say, because this is the end of each monkey is the if false, we can say self monkey push monkey clone, and then monkey equals, actually, do we need to clone it, or can we just, oops, can we just push it and then just say monkey is monkey default to create a new monkey? Let's find out. And then that's the end of the if. And what do we got? Line 37. Okay. What's going on here? Old. Oh. Did I miss it? I did miss that. Look at that. Old times old. Oh dear. Okay, so this makes it a little more complicated. We can just say add self and mul self. And then we can check here. If words, this is a little awkwarder. Awkwarder is an awkwarder word. 5 is equal to old. Then op add self else. And we do the same thing here. If words 5 is old, then op mul self else. Okay. Oh, look at that. We got all the monkeys. So we have 8974. I'm using the real input, so we should take a look at that. $89.74. We're going to multiply by 5. The test is a 17, and then we have 4 and 7 for the two monkeys. Okay, perfect. And what about the old times old? There it is, monkey 6. Has items 63, 93, 55. The op is mul self. Perfect. Okay, test 5. And then the dest is 3 and 1. All right. So I think the hard part's done, right? And now comes the easy part. We can just create a, oh, I don't even remember what we were supposed to be doing. Oh, right. We run for 20 rounds, and then we multiply the two largest. Okay, so I'm going to create a round function, which just operates on a monkey array, fn round. Let's call it monkey list, monkey vector. Yeah, which is just going to be a mutable, because we have to move all the things around in the monkeys. So it's going to be a mutable vector of monkey. And it doesn't return anything. And what we need to do is say for m in mvec. Oh, we can't. We can't do that because I need to be able to modify different monkeys at the same time. Right? If I just did this, it's going to say that this monkey needs to toss something to, you know, monkey 2, right? So if we're on monkey 0, we want to toss to monkey 2, but we have a mutable borrow on monkey of 0. We can't take a mutable borrow on monkey 2 and insert the item. Even though it's a separate item, because it's in the same vec, you're taking a mutable borrow into the vec. I think what we can do it this way though, right? For index in 0.mvec, and then just borrow that way, right? We can say let Oh, we can't say let monkey. Okay, so what are the operations? We need to inspect the item, do an operation on it. Okay, monkey inspects an item with a worry level of 70. Okay, so what we have to do is we have to say while let some item is equal to mvec dot items dot. Oh, we have to do it in the same order. Oops. All right. Use standard collections vec deck. And now this is going to change a few things here. This will be a vec deck. That way we can pull them off the front and pop them onto the back. Push them onto the back. Which means this can, I wonder if this will still work as a collection, collect here. Hopefully it will. So we can say, now we're going to say pop front. So while there's an item to process, we want to worry levels multiplied by 19. So that's our op. So we can actually make that as an op. We can say let worry is equal to mvec of I dot op on item. And so this will do the operation, and we'll write that code in a minute. Monkey gets bored with item, worry levels divided by 3. Okay, so just divide by 3 there. Current worry level is not divisible by 23. Okay, so this is just this mvec of I dot test. If worry mod that equals 0. So now we know it's divisible, it's true. We're going to give it to the true monkey. mvec dot mvec of I dot dest dot 0 dot push back worry, right? We're pushing the worry level as the item. Okay, that's correct. Else we do it to monkey 1 or dest 1. Is that all we need to do? And now we just need to write op. Right, and then we just go through the remaining monkeys. Okay, so let's write op now. Simple op. Fn. Oh, we have to actually call it something. Op calc. Let's call it calc. Calc self and val and return it an I32, and now we just match self, right? If it's add self, actually let's just copy paste. Self. I forgot you could do this. Self. And then this just becomes val plus val. This becomes val times val. This becomes n and n. So this becomes val times n. And then this becomes val plus n. Is that it? And now I should be able to do one round up here and just print it out. Let part 1 equals self monkey clone. I'm assuming that I'm going to need it for part 2 unchanged. So that's why I'm cloning it here. If I say println part 1, then round part 1, and then print it out again, and just see if we get something here. Does this build? Does it work? Does it run? It does not. Oh, that time I remembered. Oh, we can't clone. Right. Wagaffa says, when you push back, won't the monkeys be out of order? Monkey B0 be at mvec len. Oh, yeah, I'm not moving the monkeys orders. I'm moving the items onto the items list. That's a good point. I messed up. Item. Thank you for... That would have been bad. Oh, and this calling that out. Oh yeah, see, now we have this issue here. So what we'll just do is say let dest equals this. We put this here. Call it dest. Put a semicolon there. Get rid of that. Get rid of that. Get rid of that. And get rid of that. And I messed something up. Let's see what the mess up is here. That's the while. Oh, yeah. Extra bracket. Okay. So it dumped it out. It took 3 milliseconds. Okay, so here's one round. Should we use the test input just to see if the first, because I think they have the first round output after round 1. Yeah, so we can at least look to see if that's correct and then just go for it. All right, let's grab the test input. And he always has it set up so if you triple click a section like this, it just selects the whole thing, which is nice. So test input.text. All right, and then I'll change this here to just be test input.text, like that. And let's see, so after one round, it should be 20, 23, 27, 26. It is. And the next one should be 2080, 25, and so on. 2080, 25, 167, 207, 41, 1047. Okay, I think we got it. I think we got it. Let's not print all these things out anymore, because now we have to do 20 rounds. And then we need to find the monkeys with the most. Oh, right. Guess what I missed out on the monkey stuff? My monkey business. I need counts. Right? Because we need to count the total number of times each monkey inspects something. So mvec dest items, and then we just say mvec i.count plus equals 1. Right? And then let's just print out, yeah, we're printing out part 1. So we can at least see it should be 101, 95, 7, and 105. Where is it? Here's 101, 95, 7, and 105. Okay, so I think we're counting correctly. So now all we need to do is let monkey business equals part1 dot iter dot map monkey into monkey dot count. Oh, we need to the top two multiplied together. Collect vec of usize. Right? And then so we don't actually need that. We do need it because I want to say monkey business sort. And then the answer is going to be the top two. B, compare it. A. Oops, I missed a semicolon. And I missed this here. Monkey business of 0 times monkey business of 1. Nope, no semi on that one, but a semi there. Okay. What do we got? 10605. 10605. Perfect. Okay, I think we got it. Now it's just a matter of using the real input. And we get this number. 120,056. All right. Not too bad. let's see what Clippy says, and then we can commit these changes. Clippy thinks we can do better. All right. Let's see if we can do this. Oh, yeah, 42. Okay. Oops. Oh, this is the wrong file. This guy. Oh, I see. Yeah, this is kind of an awkward way to parse it, right? What's Clippy saying is do this. That goes on that one, that goes on that one. So we could do this. But this makes this kind of awkward. There should be a better way to do this. Hopefully this is still the same number, 120.056. All right. Git add source, git commit. 2022, day 11, part 1. All right, so let's take a look at part 2. You're worried you might not ever get your items back. That's a lot of worry, right? So worried, in fact, that your relief at a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Unfortunately, that relief was all that was keeping your worry levels from reaching ridiculous levels. You'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. With these new rules, okay, so the new rules are don't divide by 3, and instead of doing 20 rounds, we do 10,000. With these new rules, you can still figure out the monkey business after 10,000 rounds using the same example as above. After 10,000 rounds, the 2 most active monkeys inspected the items this much, and so we get this number. Okay, so we're going to need the test input again. Good thing I didn't delete it. Test input.text. There we go. We'll run that again for the test data. And now, so if we don't divide by 3, we're going to blow up, right? I think that's what they're saying. This is a little silly, but it keeps it as one line of code. So we still get the same value for the test data. And we're going to still do this monkey business stuff here. So this basically all comes and we just change it to 10,000 and false, right? And let me just see what blows up. So we're no longer dividing it, and we're going 10,000 rounds. And we want to change all these 1s to 2s. All 3 of them. All right, what blows up? Attempt to multiply with overflow. Okay. And that, it doesn't say what the numbers are, but I'm guessing what we need to do all right, so obviously we have to mod the numbers that we're getting here, but we can't just mod the number by the individual monkey, because it's going to a different monkey, and then that monkey has its own mod value. And it's kind of significant that all those are prime. All the tests are prime. I don't know if they are in here. Are they? 23, yeah, they're all prime. So there's no common. So I think we just have to multiply them all together and then mod it that way. So what we can do here is say if part 1, then do 3, divide by 3, else mvec I op calc Oh, we can't call it mod. We can call it mod val is equal to mvec dot iter dot map m dot test dot product. Doesn't like that. We'll figure it out in a second. Item mod val. Let's see what's wrong with this. Oh, we're still multiplying with overflow, even though I'm modding it. And it's when we're squaring it that's causing the happen. Oh, no, yeah, I'm modding it by mod val. I mean, this seems like the right thing to do. But item... Well, okay, let me just try this. I32, we're going to change all the I32s to I64. And see if that gets around the problem. Oh, okay. All right. Maybe that was it then. Let's see if this is the answer. I mean, this seems like the right approach. So that's not the right answer. Our answer is too low. Dang it. So close. Wagafa says, isn't doing the square first, therefore overflowing? Yes, that's exactly right. It was doing the square first and overflowing. Am I doing this wrong? Actually, I can pull this out of the loop. This doesn't need to be done every single time. And I am doing it 10,000 times. And I'm cloning the monkeys. So it's not like I'm using the wrong... Oh! I'm still... Duh! That's why it's the wrong answer. I'm still using the test data. 271.331.0158. Perfect. Okay. We got it right. All right. Let's try it with the real. It took a long time. Ooh, that took even longer with 8 monkeys. All right. There we go. That's the right answer. Yeah, Wagafa says, think you're on test input there. Yep. You called it. You called it. Okay. That was mostly a parsing problem, but I guess the cleverness you have to come up with here is figuring out that you have to mod. I mean, they kind of hint at it, right? Saying, oh, you have to come up with some way of find another way to keep it manageable, meaning keep the numbers in a specific range. And the only way you could mod the number is if you take the product of all... Actually, you could use, what, least common multiple here? If they weren't all primes, you could just use least common multiple, I think. But the fact that they're all primes, product works. And even if there aren't primes, product will still work. It'll just be bigger than it needs to be. Yeah, and then the last thing was it overflows I32. Okay.